All right, today we're going to dive into something that's absolutely key for building secure, multi-container apps, Podman networking. It's the secret sauce that unlocks safe, controlled communication between all your services. So let's get right into it.
So, picture this. It's a classic situation every developer runs into. You've got your app broken down into these nice, clean services, a UI, an API, a database. But now, how do you get them talking to each other? And more importantly, how do you make sure they only talk in the exact way you want them to? This isn't just a networking puzzle. It's a fundamental security and architecture challenge. And that's the real challenge, right? The goal isn't just to get them all chatting. It's about controlled communication. We want to build very specific, very secure pathways for our data and just block everything else by default.
And here are our rules of engagement, laid out perfectly. The UI, yep, it needs to hit the API to get its data. The API, of course, it needs to talk to the database. But, and this is the big one, the UI should have absolutely no way to talk directly to the database. No way. That's a huge security hole we need to slam shut.
So how do we do it? The solution is just brilliant in its simplicity. We create isolated networks. Think of it like this. Imagine your services are rooms in a high-security building. We're going to build a special, secure hallway that only connects the UI room to the API room. Then we build a completely separate hallway that only connects the API room to the database room. There is simply no door, no hallway that leads straight from the UI to the database. It's just not there. That isolation is what keeps everything safe.
Okay, so how do we actually build these secure hallways? Well, your main tool, your magic wand for all of this, is the Podman network command. This one command is the key to everything we're about to do. And here's the toolkit you get with it. You can create new networks, of course. You can use ls to see what you've already got. Inspect is super useful. It gives you all the nitty-gritty details. RM cleans them up when you're done, and the really powerful ones, connect and disconnect, which let you add and remove running containers from networks on the fly. You've got total control.
All right, enough theory. Theory is great, but let's see how this actually works. Let's get our hands dirty and see what this looks like in the real world. Honestly, it boils down to this super simple two-step process. Seriously, that's it. Step 1, you create your network. Podman network create. Give it a name. Step 2, when you launch your container, you just tell it which network to join with the -net flag. That's the core pattern you'll use over and over again.
Now hold on, before you run off and try this, there's a really big gotcha you need to know about. It all depends on whether you're running Podman as the root user or as a regular non-root user. These differences can definitely trip you up if you're not expecting them.
Okay, listen up, because this is super important. When you're running as root, what we call rootful, Podman automatically sticks your containers on a default network called Podman, but its DNS is turned off. Now, on the other hand, when you're running as a regular user, rootless, Podman does not attach your container to any network at all. So for your rootless containers to talk, you have to create a network and put them on it.
So that naturally leads to the number one question and the number one error people hit. What happens if you're running rootless and you just do a Podman run and you forget the -net flag?
You're going to see this. If you start a container without a network and then you try to connect it to one later, you'll get this weird-looking error about pasta. Basically, the default networking mode for rootless containers is simpler, and it just doesn't support being attached to one of these more advanced bridge networks after it's already up and running.
And the fix is, well, it's simple, but it's final. You can't fix that running container. The only way to solve this is to delete the container and start over. But this time, remember to add that -net flag right from the beginning. It really drills in that two-step workflow, right? Create network, then run with network. Okay, so you've made it this far. You've created your network, you've attached your containers the right way. Now we get to the payoff. This is where all that setup becomes totally worth it. Let's talk about the magic of container DNS. I mean, can you imagine having to look up the IP address of your database container every single time your API container restarts? What a nightmare. IP addresses can change, they're hard to remember. It's just a fragile way to build things. There's got to be a better way, right? Yes, there absolutely is a better way. When you create a network with Podman, it automatically turns on DNS for that network. What does that mean? It means containers on the same network can find each other just by using their names. The network itself handles the magic of turning that name into the correct IP address for you. And this right here,
is the magic moment. Let's say you have a container. You named it Nginx container. From any other container on that same network, you don't care about its IP. You just curl http://nginx container/8080. That's it. It's clean, it's stable, it's readable, and it just works. This is how you build real, robust applications.
So when you peel it all back, what have we really been talking about? We've talked about creating networks, about DNS, but at its heart, this is all about isolation. And isolation is the absolute bedrock of security. So the real question is, now that you have this power to build these secure, isolated systems, what are you going to build with it?